Hello everyone, this is Vedant Deshmukh over here. I am. Hello everyone, this is Vedant Deshmukh over here. I am the chairman of Vedant Days. No, this is not required. Hello everyone, this is Vedant Deshmukh over here. I'll be providing you with video explanations of whatever doubts you have got, or whatever chapters that you feel like should be explained in a one-on-one manner. So here we are. Let us talk about electricity today. So let us talk about electricity. So we all know that there are charges. Charges can be either positive or negative, right? Now, these charges, which are either negative or positive, have some kind of attraction force or repulsion force amongst them. Either attraction, or, as we know that unlike poles attract each other and like poles repel each other. Okay, so what I'm trying to say over here, I'm trying to give you the concept or the relation between flow of electron and, just a second, flow of current. Now, these may seem relatively easier concept for you all, because it is something that is very common, but in terms of understanding it in a better manner, we have to go into the depths of what actually lies behind the concept of a positive flow of current and the same direction flow of electrons. So since you have gained a bit of knowledge on electricity, I'm not going to go into the depths of this chapter. I'm just going to be superficial. So let me draw a circuit diagram. We have a resistor, conducting wire, an ammeter over here. Then we have a battery. And then there is a key over here. Correct? This is a, relatively, what you can say, this is a relatively easier circuit diagram than what you see in your normal textbooks. So this is a resistor, let's say R1. This measures current, let's say I. This has an electromotive force of, let's say, V volts. Now, as we all know, electrons, they have negative charge on them. They flow from the negative pole to the positive pole. Okay, so this arrow indicates the flow of electrons. Now, current, on the other hand, flows from the positive pole towards the negative pole, because current has positive charge on it, right? Current is basically a positive entity, what you can say. Now, there are two different types of current. We have current, and then there are two different types of it. It is categorized into direct current or DC current. You can say just DC, you can say, or you can say alternating current or AC current. Correct? Now, let us look at what it actually is. So, DC current ka graph, if I draw over here, it would look something like, I'm sorry, it would look like just something like this. What does this graph indicate you? This graph indicates that DC current has always a unidirectional magnitude, unidirectional, I'm sorry, unidirectional magnitude, and it does not change its direction. Whereas if you look at the graph of alternating current, let me just draw a line over here for you all so that it is more easily understandable. Now, if we look towards AC current, its graph, upon connecting to some spectrometers and appliances and all, you will find that graph goes like this in terms of AC current. Now, why this is happening so? Because alternating current has bidirectional magnitudes. Bidirectional magnitudes. And it changes its direction. So, for example, let's say this crest over here and this trough over here has a difference of, let's say, 10 amperes. Ampere is the SI unit of current. So, let's say this is 10 over here, this is negative 10 over here. So, we can say that alternating current alternates between the two present frequencies. So let's say there is positive 10 ampere right over here, there is negative 10 ampere right over here. So it would alternate like this. You see my hands? It would alternate like this. Now that we have talked about AC current, what actually lies, behind the source of DC currents? Let's talk about DC currents. Sorry, direct currents. What lies behind the concept of direct current? Now, direct current, as I told you, is a current which is of constant magnitude. And it flows unidirectionally. Okay, so how are we say that if, for example, let's say there is nature. Let's say this is water, then there are some trees over here, and there is sunlight. We say, right, ki there must be some creator. This tree must have some creator. This flowing stream of water must have some creator. In the same way, we need to understand that direct current has also a creator. And what is that creator? That creator is indeed a battery. Battery, or you can say a dry cell. Don't forget to mention dry over here. Okay. Now, let me show you how a bulb how a cell looks like. So, let us say this is the outer covering of the cell. Pardon my drawing, it is, really bad. And here is the positive pole. right? And here is the negative pole, and it is connected to some circuit. Now, what actually lies inside the circuit? Inside this cell? There is an electrolyte solution present inside this cell, which is non-rechargeable. So let me define you what are the various components of a bulb. A cell. So this is known as the brass cap, made out of brass. So therefore goes the name brass cap. Now the outer covering is made out of zinc. So it is known as zinc case. This is again a brass cap over here in order to conduct electricity. Why brass is chosen as the contacts of the cell? It is done so, first of all, in order to prevent oxidation. Then secondly, in order to prevent mishaps. Okay, so these two are the sole basic reasons why a dry cell is made into use. Now, let us look at the types of cells. Yes, there indeed are two types of cells. The first one is a primary cell. The second one is indeed an accumulator. Accumulator, or you can say the secondary cell. Okay, so now what are primary cells? Primary cells are basically those kinds of cell which has, let me just make one partition. So they have what we call as an electrolyte solution present in them. This electrolytic solution is, just you can say a result of the, what you can say, then irreversible chemical reactions happening inside. That is due to this electrolyte solution. While on the other hand, okay, let me just not give you the difference right away. Let me just tell you the basics of a primary cell first. Then we move on to the accumulator types. Okay, so these provide, as I said, irreversible chemical reactions via the electrolytic solution. Now, as we know, whenever a chemical reaction happens, there is there is some kind of tendency that, for example, if I am combining two elements together, they are of different valencies, they have different nature, they have different chemical and physical properties. If I am combining them, there is a outburst of free electrons, right? Now, this free electrons is actually beneficial for whom? For the circuit, for us, because free electrons is actually what conducts the electricity, right? I told you in the beginning that current are just reversed form of electron activities. So free electrons release हो रहे हैं, उनसे current भी provide होगा circuit. Now, let us talk about the accumulator types. Now, what are accumulator types of cells? This might be a relatively new concept for you all because you might have not, you might haven't heard about accumulators anywhere, but these are actually very common in practice nowadays because, pardon me, because what happens nowadays is that we tend to, have rechargeable devices. In these rechargeable devices, such as, the table lamp, which I'm using, the laptop I'm using, or the desktop I'm using, the writing board or my phone, which I'm using, the writing board that I use in order to explain, you can say the inverter of my AC. All of these are types of, rechargeable devices. So they carry the use of accumulator types of cells. Accumulator types of cells basically have a nickel or an iron rod inside of them. They hold the charge for a particular amount of time, and when those charges dissipate into the circuit, they lose their potential to carry charges here and there. So we have to actually recharge those rods which is present inside, and we have to there is also an electrolyte present because obviously everything would be incomplete without an electrolyte. So there is also an electrolyte present. So that is what is accumulator types of cell. Now, we talked about current, types of current, and the sources of direct current. Cool. Now, what is actually, the mathematical derivation of current? So, current, let me give you the, actually the correct definition of current. So, current is equal to flow of charge at a time. We can actually define current as the rate of flow of charge. Charge. The rate of flow of charge across a cross section let me just put this on do not disturb so it won't, come in between. So it is across the cross section normal to the direction of flow of charge. Normal to the direction of flow of current. So basically rate of flow of charge across the cross section. Now, what is a cross section, you may ask? If you're relatively new with this term, be acquainted with it because we tend to use we tend to use this word a lot in physics. So a cross section area or you can say CSA or just A is it is basically this thing. Suppose we have a conductor over here. Okay, so if you cut this conductor via its cross section, that means let me give you common example of how they explain it in the schools is that let us say I have this thing as conductor over here. This is that Volonika small bottles. So I have this as my conductor over here. Now if I cut this conductor in transverse manner, That means if I cut this conductor into two parts like this, just via their cross section, so that they can be joined again. So this particular part, which has a circular end on one side, on both of these sides, they have a circular end, right? So this area is known as cross section area. So if we talk about it like this, so this would be your cross section, correct? With radius r. So area of this cross section would be pi r square, which is basically the area of circle. Because this thing is actually the area of a circle, that call it as cross section area. Because circular parts of wire are being cut into, wire is of a cylindrical manner. So if we cut into small pieces, it would each one of those pieces would be in a circular fashion. Now I said that current I is equals to Q by T. Now what does this indicate? That current is a scalar quantity. Okay. Now we can find out different values of if we look into the numericals that is being asked by this particular formula, they might ask you key, okay, tell us that if 2 ampere current, okay, 2 ampere current flows through, I'm just using short forms, flows through a particular circuit in time 3 seconds. What would be the number of charges that have passed through that particular circuit in that given time? So you just, take this over here. So your answer would be Q into Ti. We have T given as 3, we have I given as 2, so Q would be equal to 3 to the 6 coulomb. We know that coulomb is the, SI unit of charge, so coulomb it is. Now, one more thing you can say, that I is equals to NE by T, phi. The big question in Y is that why not? Because Q is equals to N into E, correct? Where N denotes number of electrons and E denotes the charge of electron. Right? So if now we have another derivative of I is equals to QT, which is NE by T. I'm sorry for the noises coming from upstairs. It is basically, some kind of relatives up over there. So I'm really sorry for that. Now, I is equals to NE by T. For example, if you want to find number of the current flowing through the given conductor in, n number of times via this many number of charges, you can find it. Okay, so just, a simple transposition here and there would make your sums very easier. For example, IT by N would be equal to E. Here is a derivative of this formula. Similarly, I can say IT by E is equals to N. Correct? In this fashion, you can find out numerous, numerous derivatives of a particular formula, which, is pretty much important nowadays, because you're going to give your this examinations, what do we call it? Your term 2 examinations that would be offline. So you need to have, faster thinking skills, and you need to spend your time less on these particular manners. Just remember one formula, that is I is equals to QT. Just remember that Q is equals to NE. Just replace the Q with this. You have two formulas already. Just transpose it here and there. You will have more than 4 formulas. So if I use and transpose this, I can create IT is equals to Q, or I can create Q is equals to I by T. 3 formulas here. In the same fashion, IT by E is equals to N. Similar fashion, IT by N is equals to E. In this way, you can find out many derivatives of just one formula. This formula we had, I is equals to Q by T. We derived one thing from it, then we derived another thing from it, then the rest are also derived from it. Cool? Isn't it amazing how one formulas can lead to so many discoveries and so many solutions? Now, let us move ahead and let us, define ampere. Now, I have told you the relation between current and charges. Now, I have given you the formula that I is equals to Q by T. What is the SI unit of I? That is ampere. So 1 ampere is equals to Q, that is 1 coulomb per 1 second. I can say from this statement that 1 ampere current flows through a given cross-section area with radius r. Sorry, I can say that 1 ampere current flows through when one charge is applied across a given second across the cross-section area with radius r. I can say this. Now, what are the, you might say, okay, chalo, this to we understand. Now tell us that, we have seen that when there is kg, there is gram, there are some milligrams. In the same fashion, ampere might also have, different kinds of derivatives too. Sure, it does. It has milliamperes and microamperes. Correct? You can show milliamperes by just M and simple A, but microamperes has to be shown by mu A. Mu we know is a Greek letter, so mu A denotes microamperes. Now, I can say that 1 milliampere is equals to 10 raised to minus 3 amperes, and 1 microampere is equals to 10 raised to minus 6 amperes. In the similar fashion, I can reverse this. I can say that 1 ampere is equals to 10 raised to 3 milliamperes, and 1 amperes is also equals to 1 raised to 6 microamperes. So I can also say that 10 raised to 3 microamperes are equal to 10 raised to 6 microamperes. Sorry, milliamperes equals to 10 raised to 6. 10 raised to 6 microamperes is equals to 1 ampere. This is the relation between milliampere, microampere, and ampere. Okay. Now, ampere is the superior quality, the superior quantity. Milliampere is a middle one, the middle quantity, and this microampere is the decisive most, this you can say quantity. Correct? Now, let us move forward and let us, actually ponder upon some of the most common symbols used in circuits. You might now already know this. You might be like, why are you telling us all of this? This is not actually so important. Actually, it is important. It might ask you such questions like define rheostat and, resistance. How would you be able to answer if you don't know the diagrams of it? Diagrams are what basically, if you are a photographic learner like me, diagrams will help you in uttermost ways, in uppermost ways, to solve a particular question. Now, I remember many of the formulas using this diagrammatic trip only. I just, imagine some sorts of, if I write I is equals to qt, I would be like, ऐसे square बना दूंगा. then I would just, ऐसे करके, I would just decorate it in some fashion. I would create it my own memory castle sort of thing, and I would pursue that. Now, let us talk about symbols used in a circuit. Battery. This over here is a battery. Battery, as you can see, is a combination of cells. Combination of cells. Cells look like this. Just single, just one positive, one negative. You can see over here they have many positive, negative poles. Positive, negative, positive. Then there is negative, positive. Then there is negative. In a cell, there is only a positive and a negative pole. Now, we have over here a key that looks somewhat like this. If it is on, it looks like this. Sorry. Is on, it looks somewhat like this. When it is off, it looks somewhat like this. It also looks like this when it is on, and it also looks like this when it's off. In similar fashion, we have voltmeter over here. Voltmeter looks somewhat like this, and it is connected parallel to the given circuit. Ammeter. Ammeter looks somewhat like this, and it is connected in series with the circuit. Now, we have a galvanometer. Galvanometer shows either this or either this. This is a galvanometer. We don't actually apply galvanometer in every circuit because it is used to measure deflections. Deflections of current. You will be learning about the concept of electromagnetic induction while you're in class, and or I guess it is your next chapter only. I don't have any idea of it right now, but when you learn about it, let me give you a little bit of insight. What you will learn is that when there is a conductor and a magnet is pushed inside of it, there is current produced in some direction. Okay, now if magnet is pushed to this side, current will flow through this side. Now this will show deflection towards this side. So that is what it does. It basically indicates you where the flow of current is going. For example, you see these tail lights behind me. Current is flowing in this direction, right? So current would be flowing from this point to this point, from point A to B. Let us say this is point A and this is point B over here. So the current is flowing from here to here. So in my, in a west to east fashion. So in the same way, if I apply a galvanometer over here, this would deflect towards this side. The arrow, suppose this is the neutral position of the arrow, it would deflect towards this side. Can you see? It would deflect it just like that because this is the direction where current is flowing. So it would deflect just like this. Similarly, if I reverse the current, it would be like this. And if there is no current, it would be like this. Cool. Now, I told you about that. Now, we have resistances. Resistances look like this. Whereas rheostats look like this. Either this or just a slight slash. Either like this or just a slight slash. What is resistance? Resistance is basically the opposition of flow of electrons. Rheostats are basically variable resistances. Let's say there is a resistor of 2 ohms. That is the specific quantity of a resistor, right? But in rheostats, this quantity is not actually specific. It changes. If you like, if you just change the knob of that particular rheostat, it changes its resistance. So that is why it is known as variable resistance. Whereas this thing is known as constant resistance. Now, next thing. What do we have? I told you about resistances. I told you about ammeters and voltmeters. Now, let me actually draw a circuit and show it to you. Sorry, I forgot one thing. That is the load. Load can be either represented by this, a resistance, or a bulb, or just an appliance. That is not usually followed. You followed this one only, this thing. That would mean there is a load connected to it. Now, let us actually see how we can combine all of this. Cool. So, I have a circuit. I have resistances connected. I have an ammeter. I have a galvanometer. I have a battery. I have a switch. And over here, I have a load. We have combined everything. So, let us say this resistance is R1, this is R2, this is V, this has a resistance of R3, this has a current of I3. Sorry, that does not go into that. We have a key over here, and this ammeter shows that current I is flowing through. Then there is, a galvanometer. Now, this is currently in an off stage. What would happen if I turn on this particular circuit? If I turn on this particular circuit, as you can see, sorry, I turned on this particular circuit. Okay. Upon turning on this circuit, I see that current flows through. Let us say 2 amperes of current flow. The reading shows 2 amperes. The deflection of this meter will go to this side because positive se negative terminal pe jata hai, as I told you, current is a positive entity. So it would flow from here to here and in this fashion. Correct? Now there are resistances R1 and R2. They will oppose. The appliances would run. This electrical bulb would run. It would consume a resistance of R3. And therefore the current again goes in the similar fashion, round and round. This is what a circuit is. I'm sorry. Now, next thing. Let me give you the concept of rheostats. Not actually giving the concept. It is basically a machine like this. It has copper windings on it, like so. Then it is, connected to a circuit. Let us not make the circuit for easier reference. Just, make the coils. Okay. Now, this coil has a knob attached to it, like so. A knob over here. So when you move this knob to and fro, it changes its resistance. Let's say here it is 1 amp. Here it is 1 ohm. Here it is 20 ohm. So when you slide this knob till here, it would indicate that it is 15 ohms. It could indicate anything basically. Okay, so that is the concept of rheostats. How it is connected? It is connected in series. So if I actually show you how it is connected, rheostat, yeah. is connected like this. This indicates that it is variable. Like I can, if there are trust and trust in this particular thing, I can just, select one thing and it would have different resistances at different given points. Same I cannot do with normal, I can say normal circuit. Now, in this circuit, if I want to apply a voltmeter, I would apply it parallelly to the given circuit. Cool. Now, next thing, we have the concept of conductors, insulators, semiconductors, and superconductors. अब तुम लोग बोलोगे ये क्या आ गया नया चीज? अभी तक रेजिस्टेंस पढ़ लिए, करंट पढ़ लिए, पोजीशन ऑफ फ्लो ऑफ इलेक्ट्रॉन्स, रेजिस्टेंसेस पढ़ लिए, इसको तो छोड़ दो. Apparently नहीं, ऐसा नहीं होता है. You have to learn this so that your life could be much more easier. Now, conductors, insulators, then I have semiconductors, then superconductors. Now, what are conductors? Conductors are basically conductors. You can, just figure out from the name that it is conducting something, thereby conducting electricity. So, a particular substance which conducts electricity is known as a conductor at a given temperature. Similarly, insulators are those which do not conduct electricity at all. Semiconductors are in fact those kind of material जिसमें if we increase the temperature or decrease the temperature a little bit, we can see the flow of electrons in them, thereby the flow of electricity. This is dependent on temperature. This and this too. Superconductors are basically conductors at their most extreme stages, extreme cold or extreme heat. So while they're at those stages, they tend to pass on electrons so quickly that it flows in a very fast manner. Okay, so let me show you how semiconductors work. It is not related to your topic, but still, it should be taught. Semiconductors. Now, let us say we have a semiconductor over here. This is a semiconductor with length L and cross-section area A. Correct? Now, this thing is indeed a semiconductor. It is just like, a normal conductor. But what happens there? Let us take an example of NaCl. Now, NaCl is binded like this. And then, another chlorine, then another Na, then these binding together, then another chlorine, then another Na, in such fashion it is binded. Okay. Now, why NaCl is basically a semiconductor. It does not conduct, electricity when it is at its solid state, but when I dissolve it into water, when I increase its temperature from room temperature to normal water temperature, it actually dissolves. That means exothermic reaction is happening, and it would break these bonds. Okay. Now, when there is breakage of bonds, there is elimination of free electrons. So Na would release one free electron. Each Na atom will release one free electrons when it is taken at such a temperature. Now, अब हम लोग को करंट फ्लो कराने के लिए चाहिए क्या था? हमको चाहिए था free electrons. Free electrons मिल गया, so there flows the current. आया समझ में? This is 10th का concept. You don't have to ponder it upon so much कि नहीं याद ही करना. Don't do that. Okay, now let us talk about resistances for a bit. Let me just see your book for a little bit. Okay, now let's just talk about resistances, potential differences. Now, what are resistances? Resistances are those particular, materials that resist a flow of current. Now, there are two types of resistances. One is ohm, okay, just the simple R, and there is rho or rho. You can say, you can just call it rho. That is specific resistance or rho. That can be denoted, that is ohms per meter. I'm sorry. Ohms per meter or rho. Now, what is the difference between resistance and specific resistance? You can see from the word that resistance is particular. If I another again taking this, if इसका resistance is 5 ohms, इसका resistance 5 ohm नहीं होने वाला, इससे ज्यादा नहीं होगा. But अगर मैं इसका nature change कर दूं, conductor change कर दूं, तो इसका resistance अलग भी हो सकता है. Now, same concept goes for specific resistance. Specific resistance is the resistance of a conductor, insulator, or an alloy. That means a semiconductor. This particular I have over here. This is made out of metal, so it is a conductor. It might have a particular resistivity because every metal is not the same. If you look at, if you look at iron and if you look at aluminium, they have differences in them. Iron comes under the P block, whereas aluminium comes under the S block. Okay, aluminium is on the third group, whereas iron is, in the P block. Uski to baat hi mat karo. It is in the 3B or I guess 3D group, I guess. So, free electrons का difference. अब free electrons है, तो resistance कम होगा. Free electrons ज़्यादा है, तो resistance कम नहीं होगा. Now, how can I say that कि free electrons कम होंगे तो resistance कम रहेगा and free electrons ज़्यादा रहेगा, resistance ज़्यादा रहेगा. Now, see, this is a conductor. Over here, I have with me. This is a conductor, right? इसके अंदर already electrons है. Correct? Now, to this electrons, we are inducing some electrons. Correct? Electrons we are inducing. अब ये electron अंदर गया, negative repulsion, resist हुआ, ठीक है? Electron resist हो रहा है, flow of charge भी resist हो. In the same fashion, अगर electrons के साथ मैं अंदर खूब सारे भर दूं, तो जा ही नहीं पाएगा. Insulators, अगर मैं खाली कर दूं जगह को एकदम like this, तो जा पाएगा. So that is what the concept of resistance is. Now, we have the concept of potential and potential difference. Now, what is the difference between potential and potential difference? First of all, potential, you can say, is the tendency of attraction of an object. We say कि ये बंदे के अंदर potential बहुत है यार, ये बहुत अच्छा काम करेगा, right? We say that because we know कि वो person अभी जिस point पे है, ठीक है? अभी जिस point पे है, उस point से उठ के कहां पर चले जाएगा तुमको नहीं पता है, because he has potential to go there. करेक्ट? अगर तुम्हारे पास पैसा है, तुम घर पे बैठे हुए हो, sorry, I'm extremely sorry for that. हाँ, so I was saying कि तुम घर पे बैठे हो, तुम्हारे पास पैसे हैं, ठीक है? सॉरी, मेरा हिंदी थोड़ा सा खराब है. तो तुम घर पे हो, तुम्हारे पास पैसे हैं. Let's say you have 100 rupees in your hand right now. That 100 rupees you're willing to spend. ठीक है? So that 100 rupees is your potential right now. You can you can get up, go to the market and purchase yourself some cookies. You know, those nice chocolate chips ones. So you have a potential to get up from your house and actually go to the market to purchase a particular stuff. In the same way, that is potential. Potential at point A and potential at point B. Potential at point A for you was 100 rupees. Potential for you at point B was 0 rupees. Or let's say you had 50 rupees. There is a difference amongst them. That is known as potential difference. थोड़ा सा concept clear हुआ mind में? अभी हो जाएगा अगर नहीं हुआ तो. Let's say there is a charge. A charge always inhibits a field around it. Let us go a bit down. There is a charge, it inhibits a field around it. Now there is another charge, the small field around it. Okay? Let us connect these via an imaginary string. Let us name this point as A, this point as B. Now, potential at A was 110. Let's say potential at B was 100. Now, since potential A is stronger than potential B in terms of magnitude, in terms of magnitude, potential A is greater than potential B, right? 110 is obviously greater by 100 by what means 10, correct? So point A has greater potential. Now, since it has greater potential, it has the tendency to attract other molecules too. Now, अब ये attract कर रहा है, so this would go over here inside this. Okay. Now, the work done upon a charge Q is actually known as potential. Now, अगर मैं इसको उठा के इसके अंदर डाल दूं, तो I would denote it as V at B A is equals to work done upon charge P. Simple as that. Okay. In the same way, I can say that VAP is W by QA. Okay. Now combining these two will cancel out. We have VA minus VB is equals to W by Q. This is actually potential difference. And I bet तुम लोगों को ये concept नहीं समझ में आ रहा होगा, because it does not explain. The books don't explain like how I'm doing, correct? Now, let us actually read the statement, what your book is saying. It says that the potential difference between two conductors is equal to the work done in transferring a unit positive charge from one conductor to the other. That's what I said. I have two unit charges. मैंने B से A पे लाया. That was the potentials of them, potential at B, potential at A. जब मैंने उनको उठा के एक पॉइंट से दूसरे पॉइंट पे लाया, the potential difference among them is basically that. It is equal to work done upon charge Q. Cool. Now, potential is a scalar quantity. Its SI unit is volt. Cool. Now, moving on to our next thing. We talked about electrical resistances. We talked about different kinds of, appliances. Now, let us actually talk about Ohm's law now. Yes, again, like Newton, Newton तुमको परेशान किया with the three laws, which are laws of inertia, and all of those laws. अब यहाँ पर आ गए हैं Ohm's law. Ohm's law फिर से तुम्हारी जिंदगी में आके तुमको परेशान करेंगे. Ohm's law. What does this Ohm's law state? This states that the resistance of a conductor is said to be 1 ohm if a current of 1 ampere flows through it when the potential difference across this end is 1 volt. So let us, frame this. 1 ohm is said to be 1 volt when 1 ampere flows through it. Now let us, apply it in a mathematical fashion like we always love to do. Where is it? Yeah. So I can say 1 ohm. Ohm किसका था? R का. Volt किसका था? Potential का. ए किसका था? एम्पियर। आई, एम्पियर किसका था? आई का। तो आई कैन से R is equals to V by I. First equation. If I want to calculate R, I will use this formula when potential difference and current is given. I guess my device is lagging a bit. No, it is not. In the same fashion, I can transpose I to R. So it would be IR is equals to V. Second equation. Yes, there is a bit of latency. It would get better in a bit. So it should get better in a bit. Okay. It would eventually. Now, in the same fashion, from this statement, I can say that I is equals to R by V. If I transport R over there. Now, देखा तुमने कैसे by just using one statement we created two more statements out of them. Now I can also say that V potential difference is applied when R flows through I in a particular time. There is also time, but time is constant, so we don't count that. In the same fashion, I can say that 1 ampere is the current flown through a particular given conductor when there was a resistance R and a potential difference of V across it. Correct? Now, ये वाले फॉर्मूलाज अच्छे से याद कर लेना, इसका स्टेटमेंट भी अच्छे से याद कर लेना, ये बहुत पूछा जाता है. लाइक योर द एग्जाम वाले जो रहते हैं ना, वहां पे उनका फेवरेट क्वेश्चन रहता है बेसिकली. ठीक. Now, is there anything else? There is efficient use of energy. Now that we know each and everything, how can we consume energy? Like, how can we conserve energy? So let me give you two more derivations, which will be useful for you in your class 10. First is power, which is power is VI. Energy is V. Oops. V I T. ठीक है? So, power. We can say from here that power is directly dependent on V and it is directly dependent on I also. You know, instead of this, I can give you another derivation. Let us say power is I square R. Okay, so power is inversely proportional, is directly proportional to I ka square. Power is directly proportional to R. ठीक है? Now, efficient use of energy. What do I mean by efficient use of energy? Efficient use of energy is basically the use of energy which fulfills your need without, hampering the needs of others. And it is also economically feasible. Now, I said to you that power is directly proportional to I square, power is directly proportional to R. Now, when you turn on some kind of bulb, it has a rated ampere, it has a rated R. Now, let's say the ampere was 25 into R. R was 2. So power मेरा आ गया 50 watts. Correct? Power मेरा आ गया 50 watts. 50 watts is a lot of power. It is 1,100th a unit, which is 1,000 watts, which is a lot. So, efficient use of energy is very, very important. उसको explain करने के लिए कुछ नहीं है. You can just explain by your own means using. You can also use this formula, but don't, because even if you use, I shall not be liable for it, because this is actually 10th ka topic and you should not include there. But still, you can just mention ki how can you can have an insulating home properly. There are no leakages in the wire. Then you can say that we should use CFLs more, we should use LED lights more, we should promote the usage of these small fairy lights, because they are cheap, they use very little power. Like each of this what do you call it, each of this LED light is, I guess, 0.0001 ohm. and when you combine all of them together, it actually results out to be 1 ohm, and the current it consumes is around 1 ampere. So total power consumed is 1 watt per hour. So just imagine a bulb which is consuming 1000 watts an hour, and this thing which is consuming 1 watt an hour, which is efficient. Obviously, this they are providing the same amount of light, they're providing the same amount of everything, but still, why fairy lights are better? Because they are cheap. They will be cheap in the long run. Okay, so accordingly, you have to think. Why you should think that use of coolers or use of fans should be more than AC? Because AC consumes around 1000 watt of power in a particular given hour. So एक यूनिट का कंज्यूम करेगा, which is a lot. अगर देखा जाए तो 1 hour is equivalent, sorry, 1 unit is equivalent to 7 rupees nowadays. It might be different in your areas, but here it is 7 rupees. If I operate my AC for 5 hours every day, straight for 31 days, how much do you think that would be? Obviously, it would be 5 and the 5 has the 15, 155. Now multiply it by 7. 7 5 the 35, 7 5 the 35, 3 over here, 35, 36, 37, 38, 3 over here, 7 the 7, 8, 9, 10. 1800, 1085 तुम्हारे AC का ही charge आ रहा है गर्मियों के टाइम पे. That is why use of cheaper electronics is always promoted. Now, if you use your AC, उसमें से CFCs release हो रहे हैं. It is also not, it is not actually feasible for the economy. So in that particular way, you can just, tell the differences between an efficient energy use. Now, let us actually look at some of your questions. Let me see one thing, if that derivation is given. I guess not. No, that derivation is not given. I was hoping it was to be given, but still, it's okay. You'll come to know about it when you're in class 10th. That is the derivation between rho and resistance. That is rho L upon A R. So let us look at some of your questions. Then we will end the session. First question says that what is responsible for the flow of current through a metallic conductor and an electrolyte? Now, I told you in a metallic conductor there are 3 electrons. Therefore, they are responsible for the flow of current in a metallic conductor. Similarly, in an electrolyte, I should tell you that electrolytes are always ionic solutions. Electrolytes are always ionic solutions, correct? So these ionic solution has both positive and negative charges, which is corresponding the flow of current. Question number 2. A conductor carries a current of 0.2 amperes. I is 0.2 amperes. Find the amount of charge that will pass through the cross section in 30 seconds. Q we have to find out. Time we have been given 30 seconds. लगाओ formula I is equals to Q by T. I को उधर भेजो. We have 0.2 into 30. We get this as 60. We have Q. So 6 is equals to Q. 6 coulomb is equals to Q. Correct? Now, how many electrons will flow in this time interval if charge on one electron is 1.6 into 10 raised to minus 19? Now, I told you that अगर कुछ नहीं दिया है, if it is given in a time interval, ठीक है? Just assume कि it is saying 1 second. 1 second मान लो, question बन जाएगा. In a time interval basically means 1 second. ठीक है? So I can say N is equals to Q by E because I said Ne is Q, correct? तभी तो निकला था ना हमारा Q is equals to IT वाला formula. Sorry, I is equals to Q by T वाला formula. Sorry, I is equals to Ne by T वाला formula because यहाँ पर क्या था Q था, and I told that we can write Q like this. So I can also write n is equals to q by e. ये भी याद कर लो, ये वाला भी फॉर्मूला याद कर लो, ये भी याद कर लो, सब याद कर लो. It would be easier for you. Okay, so I have to find n. I have been given q का value. I know 1.6 into 10 raised to minus 19. I guess, yeah. Divided by. Sorry, मैंने उल्टा कर दिया. This is e. I can write like this. This 6. Reverse कर दो. N is equals to 6 by 1.6 into 10 to the power minus 19, which is almost equivalent to, if I cut it, it is 3s are 7, 3.75756, I can say, or just let's say 3.75. ये ऊपर जाके पॉजिटिव में चेंज हो जाएगा. ठीक है, 19 भी नो राइट कि जब भी डिनोमिनेटर में एक्सपोनेंट रहता है वो न्यूमरेटर में तो जाएगा तो वो पॉजिटिव हो जाएगा. So it becomes 3.75 into 10 raised to 19 number of electrons. Now, let us look at more questions. You can solve exercise 9a by yourself. It is just, the difference. Primary cell, secondary cell, differences. I have told you what is in charge of an electron. It's given over there. Now, no numericals are there, surprisingly. Cell is connected to a bulb which develops a potential difference of 12 volts across. This is related to Ohm's law. Whenever you see volt, ampere, resistance, सीधा सीधा Ohm's law लगाओ. That is V is equals to IR. ये याद करो, ज्यादा इजी रहता है. ठीक है, ये याद करोगे, I को इधर भेजो, V को उधर भेजो, आंसर आ जाएगा V by R. R को इधर भेज दो, R by I. हो गया, डन. So, सीधा सीधा ये लगाओ. क्वेश्चन क्या कह रहा है? क्वेश्चन हमारा कहता है कि we have been given a voltage of 2 volts, V is equals to 12. The circuit is measured to be 2 amperes. I is consumed to be 2. So I can just apply R is equals to I by V. I will have 2 by 12. Sorry, V by I. I'm extremely sorry. It would be V by I. It would be 12 by 2 is equals to 6 ohms. Quantity लिखना मत भूलना. इसके हाफ मार्क्स लगते हैं, इसके हाफ मार्क्स लगते हैं. इन टोटल 1 मार्क्स क्वेश्चन है along with this. ठीक है, तो मार्क्स मत गवाना आपने. ठीक है, सिमिलरली ऐसे ही क्वेश्चंस आएंगे. ठीक है, उसमें यू कैन बी आस्क्ड एनीथिंग. ठीक है, वर्क डन के ऊपर क्वेश्चंस आ सकते हैं, तो W is equals to QV वाला फॉर्मूला लगा लेना. दिस इज अनदर डेरिवेशन फ्रॉम द टॉप. ठीक है, ऐसी करंट आते हैं. I hope you're able to solve them. Now let us see exercise 9c. What is meant by efficient use of energy? I told you to select 2 ways. You can write by yourself. IEA is a short form of International Energy Agency. You should know that. It is in USA currently. Which of the following devices is the most efficient for lighting purposes? They are CFLs. Okay, LEDs and CFLs. So I hope you liked this session very much. If you have any of your doubts, you can just call me at my personal number if you're on the WhatsApp group, or you can just leave a text on our WhatsApp groups and we will get right back. Thank you.